I helped you to understand the intuition behind using right, the ANOVA test, how to perform ANOVA test, and also we discussed about one-way ANOVA, which is nothing but one factor ANOVA. So in this case, shelf space is a factor, right? So we analyzed, as per this case study, we have conducted the one-way ANOVA test to understand does shelf position have any influence on the sales. Okay, changing the position of the shelf does have any influence or any increase in the sales. That's what we understood. And also we have taken a look at the ANOVA two-way test, two-factor ANOVA with the replication, without replication. And as part of ANOVA one-way, and all these three tests, one-way, two-way, ANOVA with replication, without replication, we have seen how to do the test using Excel sheet, and manually how do we do the calculation. Now we will take a look at how to perform the Chisq test and start Python. Okay, so here the same thing, we will start with the same case study, and then we will see how we can do the ANOVA test using Python packages. Okay, import NumPy. NumPy is one of the common package, pandas as PD, and I'm going to import matplotlib.pyplot. And we have something called stats models dot stats dot one way as one way. Okay, as sort of stats models, there is something called stats dot one way sublibrary itself available, using which we can conduct the test. Okay, matplot, spelling mistake. Okay, till it imports, right, let's not wait, and I'm going to key in these values to the package. Okay, so we have a method called one way, the stats dot one way, right? So we need to pass the values in order to do the test, right? So what we will do is we will first create some data frame, and what I am going to do is I'm going to say d1 is equal to pd dot data frame. And how many of you remember the static way of creating data using data dot frame? So here I just say values, and see here I've used the dictionary curly braces. The dictionary is the curly braces one. And the dictionary, you know very well, it'll have the key and value pair. 2 3 will put 23726, right? 7 comma 2 comma 6. For position we will use next one is how much we have. 10 8 7 5 10. Okay, same thing, I'm going to put the same data here to conduct the test in Python. Okay, let me see why somebody is calling me. This is my front shell. So we have something np dot repeat, using which we can repeat the top, all the things. But anyhow, we will, in the interest of you people to understand it, right? I just put it this way. I just execute it. Yeah, no error, good. And I'll do it. Okay, so for no error, and now I just use concat function. I just say d1 comma d2 comma d3, and here I just say df. Now it is ready. Okay, so one is holding all the sales values and other one is the position. So all the values got stacked on top of one another. So look here, the top got stacked on top of mid, and the mid got stacked on top of front. So this is how we have used it. We have np dot repeat, using which instead of copy pasting 5 times, you can use np dot repeat. We will see it later. Now my data set is ready. Just quickly go and verify this. On top we have 23726, 23726, and mid shell 1087 510. Yes, it's all good. And the next step is one second. Keyboard is very hot. And next one is, I'm going to plot this one in the box plot. Okay. SNS dot box plot, we have seen it already. Ex equal to x-axis position, and the y-axis, this is the one, values, right? So values, and the next one is x-axis, y-axis, and you need to say which data set you are going to use it. And I'm going to say color. I don't want to use any color. Let it use the default one. Look here, the position got plotted in this x-axis. In the y-axis, values got plotted. Now with this we can see that in the front axis the median cell is almost 13 here, right? So compared to the other position in the shelf, top shelf, the median sales is lesser than the mid position sales, median sales. The middle one is the median. Okay, this line is the median. Okay, and this is also median, but here just beneath this we don't see anything, and we have one outlier here. With box plot we can understand, we can find out the outlier. So everything is good. Now what we will do is I'm going to use okay, and here I just say everything is ready, right? Okay, the next one is the one-way ANOVA. So one-way ANOVA, or else we can put it this way also. Let's say top is equivalent to how much we got. Okay, let me, instead of wasting time, I just go up and take this value. See the another simple way of doing it. Okay, instead of creating data frame, all the things, simply you create 3 lists, and each list hold the value of your this one and front, and my front is this one. Got it. The next one is stats. Simply we have some stats dot f one way, and see the ANOVA test is also called as a f test. Okay, and here there's a f underscore one way, f test one way. Here I'm going to say top, mid, front, and then here use variance equivalent to equal. Okay, I just specified it. Let's assume that the variance of all these 3 groups are same. Sorry, this is the one we can use it with ANOVA one way. Yeah, now I remember. So here we have something called we simply specify we remove all these things. Yes, now I can see the p-value as 8.53. This is somewhat p is less than alpha, right? E minus 0.5, 0.0000853. Okay, so this obviously this p-value is less than alpha, hence we can reject the null hypothesis. Here we got 22.59. Look here, the f statistic. The f statistic value is 22.59. And if the critical value is 3.89, obviously this one falls under the rejection region, because the 2.29. So this is one way of doing it. Simply you just go by p value. If the p value is less than alpha, what do you say? Since p value is less than alpha, since p value is less than alpha, reject h sub 0, right? That's all. This is one way of doing the ANOVA test, and we have another method that is available here in Python. So one way dot ANOVA one way. This is another function. See, there are 2 different ways we can do it. In stats package itself, we have a method called f1 way. This is the one is available. And apart from this, we have stats dot f1 way, top, mid, front, same thing, but variance equal, right? So here we are assuming that all the groups variance are equal. And if you see this, the p-value is 0.006. There are 2 things. One is variance, by default it is false, right? It is not equal, and in that case you will get different value. So that is what we can see, the 22.59, something like that. P-value is 0.005 something, but here 0.0006, right? So here equal. Okay, one second. This is not. One second, this is not okay, this is, sorry, I just removed this one. That is the one was throwing an error, right? So there is nothing called use var equal option is there. But had I executed this, it would have thrown an error like how I got it earlier, right? How I got the error earlier. See, equal. If I don't give this one, mid and front, use var. Okay, if I don't use this one, look at this p value 8.538 on the statistic value, statistic 22.59, right? So now it shows 21.53. Okay, and we are going to say use var is equivalent to all the groups variance are equal. We are going to assume it that way. Now my statistic is matching with this, and 22.59, 22.59. Got it? So that is the one, and p value is also same as that function f1 way. So ANOVA underscore 1 way is a method or function that is available. Okay, and that is the one available as part of this package stats model.stats.1 way. We have imported that one with that also, but here you can get a lot of informations. You can get degrees of freedom and number of groups and means, all the things you can get it. You can get the detailed one, but whereas it here in this case it gives us only the p value. If you know the p value, that is more than sufficient. In this case we are going to reject the null hypothesis, and we are going to conclude that all the groups means are not same. Okay, that is what we are doing. And next one is we have something called post hoc test. What is post hoc test? Anybody knows this one? We do something for that Tukey HST test. Okay, there is a HST Tukey honest significance test. Okay, and difference test. So what we do is I explained you at the beginning of the ANOVA test why we are supposed to do the ANOVA test. Why can't we use the two independent sample t-test? That time I explained you, when you let's say if you have three groups, if you want to compare the means of all the three groups, you need to conduct three t-test. It's a time consuming one, and also the alpha value, right? So alpha value, you need to, for each test you need to consider alpha value 0.05. So 0.0.0. If you multiply all the things, what happens is your risk level is reducing it, and at the same time, the risk level is increasing, whereas your confidence level is going down. That is the problem. Okay, but you need to conduct three tests. If you have, if you want to compare three groups means, or the three groups means are equal, to compare that, you need to conduct three t-tests. If you are going to use a t-test, in the past they were using t-test only. There was nothing called ANOVA was available, and someone they came up with an idea of ANOVA test. They introduced that, after which you don't have to run multiple tests. In a single test itself we can. But with this test we are able to conclude there is a statistical difference if we keep the items in different position of the shelves. Statistically different. Which one? The sales values are not same by keeping the items in the different position. The same items, by keeping the same items in the different position of the shelf, the sales is not same. There is a difference here. So we have rejected the null hypothesis. We conclude, yes, there is a difference. So with that, in a simple English, we are able to understand, or we can say, keeping the items in the different position of the shelf has an influence on the sales. Maybe it could be a positive influence or negative influence. Now, is there any way we can compare the pairwise group comparison? Can we do that? Yes, that is possible. That is what called as post hoc test. Using post hoc test, we can we can do pairwise comparison, which without using the alpha value 0.05 for each group comparison. Okay, so here group in the sense the pair. I'm talking about the pair. Okay, you remember I was explaining this one. I was explaining this one, right? So this is the one. So you need to compare this group with this group, and you need to compare this with this group, and then you need to compare this group with this group, right? So if you use a t-test, for each t-test you need to define the alpha value 0.05. So what will happen is, if you multiply all the values, your risk is increasing, whereas your confidence level is going down. That is the, that's what we have seen it. But if you use t-test, your alpha value, you need to use the alpha value for each test, but without using the alpha value for each pair of group. We can still do the comparison between the groups. That is where the post hoc test is very much helpful. And right, so post hoc test, with that we can do that. And here I'm going to import, or we have already imported one way, from stats models dot stats multi compare import pairwise to key HSD. I think it is correct. Yes, the package name is correct. Now what I am going to do is, I am going to say result pairwise to key. So don't worry, I will share this script, and also I will put it in my website. NDOC. Okay, NDOC. You know about the NDOC. You just think, this is the values. You need to specify the values, and then groups. You need to tell the groups. DF position, right? In our case, the groups were position, and alpha is equal, only one alpha value I'm going to use it for comparing all the three pairs of groups. Print, if I do it, it is not going to show anything. I'm going to use print function. I'm going to result. Look here. So it compares the front and middle. Look here, this is the one. This is your front and middle one. It compares these two, and then it compares the front and top, front and middle, and front and top. And what else? Middle and top. Middle and top, it compares, right? So it does the pairwise comparison, and then it gives us the mean difference. And this is the p value. P adjusted is nothing but your p value. Just think that way. Here, front and middle, right? So the difference is -5. The p value is 0.00. P value is less than alpha. Hence, we can reject the null hypothesis, and then we can conclude that yes, there is a difference in keeping the hydrogen. These two shells, but the difference is -5. Okay, with the difference we can see it, and then we can see the p value for this pair, and this pair it is p0 value is 0.001, and hence we reject the null hypothesis, and we conclude that the front, look here, the front and top, the sales is not same, it is different, and the middle and top, if you compare it, the difference is in -4, and the p value is less than alpha here also. In all the three cases, we can see that the sales is not same. If you keep the item in front shelf, and if you compare front and middle, it is not same, and middle and top is not same, and top and front is not same. That's what we can see. And along with it, we can see the difference also. The difference is -4, -9, -5. Middle and top, if you see, the difference is less. Right, so the difference is just because the difference is less, can we say, if I keep the items in the top and middle, does it really boost my sales? So this is my top and middle, right? So 10, but here these two are good. So why for middle and front? Middle and front, right? Middle and front, it shows, yeah. So this is 0.0075. Front and top, the front and top. Okay, this value is 0.001. Okay, and this one is 0.007, right? So with this, with Tukey honest significant test, right? So we can find out the pairwise comparison, and also it gives us the mean value for the p value for each pair, and with that we are going to reject the null hypothesis. But middle and top, the p value is not that less 0.02, but the 0.001 front and top, and this is the difference. -9 is there, right? So here -5, -4 is there, the difference. And now you tell me what is our conclusion? What are we going to conclude now? So can we say keeping the items in the front and middle can boost the sales? Front and middle, right? Front and middle 0.007, right? The difference is, we cannot go by the difference. See, middle and top also -4 only the difference. Compared to these two pairs, the difference is not much. And but whereas -4 compared to this one, right? Yeah, -5. Now you tell me -4 is bigger or -5 is bigger, or -9 is bigger. But still, if you go by these values, right, it does not make any sense. But front and middle, not the front and the top and middle, right? So top and middle, front and middle, right? Front and middle, with the first one, we can see the p value is highly statistically significant, and the difference is -5. And with this we can understand, if you keep the items somewhere in the front and middle, the sale is good, but top is not much we can expect. Okay, that is what we can conclude. So using Tukey honest significant test, right, we can perform pairwise comparison without giving alpha value 0.05 for each pair of group. Okay, in a single test with a single alpha value, you can do pairwise comparison using Tukey honest significant test. And pairwise comparison, see, just concluding with the p value, saying that we are rejecting the null hypothesis, and we are going to conclude there is a difference in game. Okay, what is the difference? Can I take a deep dive? Yes, using pairwise Tukey HSD. It's also called as a post hoc test. While conducting the post hoc test using this function, we are able to conduct the pairwise. We are able to obtain the pairwise mean difference and the p value, the lower bound and upper bound also it shows, and right. So that's what we can see it here. But net, if you in the p value in all the three cases, three pairs, I meant three pairs here, we reject the null hypothesis. Okay. But end of the day, yes, we are able to understand front and middle only can boost our sales if we keep it there, right? So that's what we are going to conclude with this one. I just say this as one-way ANOVA test. So already we have seen how to conduct the two sample t-test and t-test _ rel function and pairwise thing also. I'm yet to upload, please bear with me, will upload it sometime today. Okay, the Python script to do the, all kind of descriptive statistics and this test, right? I will upload it. You can download it and start practice it. And similarly, the assignment for you all is you try with two-way ANOVA with this one, two-way ANOVA with replication. Okay, you just give it a try. Okay, and we will look at it later. In the meanwhile, what I am going to do is, before we proceed with that one, let us understand what is chi-square test. This is another type of test that we do it. So far, all the test, whatever we have done. One second. Okay, so far we have been learning the hypothesis that one sample t-test, two independent sample t-test, pairwise t-test, and we have also seen the ANOVA test. And so all these tests we have compared the means across samples, right? So in the case of two independent sample t-test, we were comparing the means between two independent samples, or the means are same between the two groups, and even the pairwise hypothesis, we were comparing the pre and post are same or are there any difference. So end of the day, even in the case of, though the name says ANOVA, analysis of variance, even in the case of analysis of variance, we were comparing only the means across the groups. Okay, and so hence we can call that as a parametric test. So you know what is parameter? Parameter is and statistic. We discussed about that at the very beginning of, or during the time of introduction of inferential statistics. Parameter is nothing but the population mean, population standard deviation, and statistic is nothing but sample mean and sample standard deviation. Since we have conducted so far all the tests, we have compared the means only, hence it's all called as a parametric test. And what if I have two categorical variables? See, in the past my dependent variable was numeric value, continuous variable, okay, and my independent variable was categorical. For example, in the case of one way ANOVA, the shelf position, that was the independent variable, and the dependent variable was sales value. Okay, and the sales value was depending on the shelf position. Okay, and the shelf position was a categorical variable. The sales is a continuous variable. But what if I wanted to find out, are there any relationship exists between two categorical variable? Instead of using the mean to compare it, is there any way if I can compare two categorical variable? That is where the chi-square test is coming into picture. It is a statistical method using which we can find out the goodness of fit between the observed values and the expected values. So here is the formula for the chi-square test. The chi-squared is the notation is somewhat like this. This is the one, and observed minus expected whole square divided by expected. This is the formula for identifying the goodness of it. And what are the properties of chi-square? It is based on frequency, not on the parameters like mean and standard deviation. Here we don't have to worry about mean and standard deviation. We literally go by the frequencies. Okay, when can I conduct chi-square test? So far we are very clear the distinction between the different types of test in statistics, right? Inference statistics. And when can I use chi-square test? To perform association analysis. Okay, and whether two categorical variable are having any association or not. To find out that, we can use chi-square test, and also we can conduct the chi-square test for doing the test of homogeneity, to test whether the occurrence of events follow uniformity or not. Okay, and then we can use chi-square test to find out the goodness of fit of distributions. But most of the time when it comes to chi-square test, we conduct the association analysis. We will try to find out, are there any association exists between two categorical variable. That is what we say. So now what we will do is we will go ahead and take a look at the distribution of the chi-square. Okay, so if you see here, this is a family of distribution called chi-square. If you go and do googling chi-square distribution, it will be something like this. It will see even this one also something like right skewed thing. That's what I mean. As is the case with T, the determining parameter of chi-square is the degrees of freedom. Okay. So here also we need to find the degrees of freedom like a t-test. The chi-squared, we use this notation like this. Okay, and we pronounce this chi-square as chi-square. It's a family of distributions called chi-square. Okay, it will be something like this. and the distribution. And I believe all of you remember the T distribution, Z distribution is a normal distribution, and T distribution is approximately normal distribution, and F distribution was like what is F distribution? We have seen as for the ANOVA test, right? It was kind of a right skewed one, and even chi-square also somewhat it looks like this. Okay, next we will understand how to formulate the hypothesis when it comes to chi-square test. The null hypothesis, as I told you, what you wanted to reject it. What is the objective of the chi-square test? See, we are going to talk about this, and we are going to find out, are there any relationship or association exists between two categorical variables. Okay, and what we are going to reject? We are going to reject, this one. There is no association between the two categorical variables or two cross-tabulated variables. The alternative hypothesis, the opposite of this one. Okay, so now we will write the formal null and alternative. This is my null hypothesis. My outcome is independent of factor x, which means there is no relationship exists between my outcome. So I know. So I will take a look at this example, okay, and so that you should be able to understand this one. Look here. This is one of the case studies. In this case study, if you look at here, we have a categorical variable called outcome, and we have another category, hospital. So in hospital, different types of different hospitals are there, and outcome is another category. So in the outcome, we can see different groups: complete recovery, partial recovery, death. Let's say somebody wants to undergo kidney transplantation. Does kidney transplantation surgery outcome depends on hospital? How many of you agree with this or not? See, so one of your relatives, they are supposed to undergo some kind of transplantation or surgery. So before going for a surgery, what you do is you ask the doctor about the success rate. What is the success rate that this surgery will be will lead to complete recovery. Okay, and what you do is you take the data. You ran a survey, and you collected the data from various hospitals. Okay, and then you have created a contingency table like this. This is called your contingency table. In the contingency table, you specify the frequency. How many number of people those underwent surgery with M hospital, got a complete recovery. How many people had a partial recovery? How many people died? Similarly, you collected the data and you just recorded it here like this in this table. Okay, and now we need to conduct a test. Does the outcome has any association with hospital or not? Okay, and so in order to do that, what we will do is we will use chi-square test, because in this case the outcome is a categorical variable and all these falls under hospital. This is all these things are your another categorical variable. So if you want to find out, are there any relationship exists between one categorical variable to another categorical variable? In this case, outcome depends on, or outcome has any association with the hospital. And if you look at this data, you can see that Apollo hospital has more recovery compared to other hospital, partial recovery and death, and the number of death is less in Apollo hospital. Still you want to this is just sample data, so you need to conclude it by conducting the test, chi-square test. So what is the formula for chi-square test? In the case of chi-square test, you need to subtract the observed values from expected values from observed value. What is observed value? The given value minus the expected value. So what is expected value? This is where you need to concentrate. Okay, and how do we arrive the expected value? This is my table. This is my contingency table. To arrive the expected values for each cell, I need to use some formula like this. Okay, expected values, column total So what is the column total for this value? This 38 into row total. This 38, look here, this 38 and this row total, this is 176. Okay, this one into this one divided by grand total. This is my grand total. 278 is my grand total. So if you do this column total into row total divided by this one, you will get this value. Similarly, to get the expected value for this one, see, this is the actual value. You ran a survey with the different hospitals, you noted down the values. Now for each value, right, observed value, you want to find out the expected value. There is a formula for that. Okay, and for example, in this case the column total is 90 and the row total 176. These two you need to multiply it divided by the grand total. See, the grand total is this one, 278. Okay, so that is how. Now I will just show you how I got 24.07, so that in Excel sheet if I show it, you will be able to understand it. With this formula, if I show it, you should be able to understand it. Just give me a second. All of you please type it in the chat window. What is the column total for this? What is the column total? This is the one, right? 38. What is the row total? This is the one. Column total into row total divided by, this is your grand total. So here 38, column total is 38 into 176. What is the grand total here? Grand total was 278. $24.05. Look here, it is matching with this value, right? Similarly, for each and every column, we need to obtain the expected value. So in this case, what I did, I just 90 into 176 divided by 278, I was able to get 56.97. And in this case, 96 into 176 divided by 278, I got this 34, sorry, here in this case, 54 into 176 divided by this one, I got this value. This is how I got the value for each and every column. But in this case, the column total is 38 and the row total is 64, not this one. Okay, 64 divided by 278, I got this value. So likewise, you can obtain the expected values using this simple formula, column total into row total divided by grand total. Once you compute the expected values for all the columns, okay, and the next step is, see, basically what we are doing is we create the contingency table based on the survey data, whatever we received it, we put the thing, how many number of patients got a complete recovery, 18 patients, 50 patients got complete recovery, we noted down, and then here we find out the row total. So this one gives me 176 and this row total gives me 64, this gives me 38, and you need to add all these values, you will get 278. And similarly column total, you need to do it. So here already we did 38, 90, 96, 54, these are the column total. Once you have the column total and row total and grand total, and obtaining the expected values are pretty simple. And then in Excel we have a function called Chisq Test, and in this one you need to select all the observed values. So CF3 to CF8, nothing but all the observed values, comma all the expected values. You are not supposed to take into account of this row total, column total, grand total and all. You need to take into account of only these cells. Okay, I just highlight that one. This is my observed value and this is my expected value. Sorry, this is the observed value, this is the expected value. Okay, the inside the rectangle here. So this is my observed value, actual value, and this is my expected value. Right, you need to specify the range, it will give you the p value. It's pretty simple. So now you tell me p value is this one, and can you reject the null hypothesis or not? can you reject the null hypothesis or not? So in this case, using a simple chi-test, we know what is the observed values and what is the expected values. When I pass this one, it gave me a p-value as this one, 0.00064. So can I accept or reject the null hypothesis? Palani, what happened, Palani? Jivanandam, p-value, are you there?
Yes, sir. I mean,
All of you are busy with Sunday, right? Sunday evening, you are all busy. Okay, and tell me
today is
what.
Saturday, sir.
Oh, sorry. I am working, 7 days per week. That's very good. Sumati, very good. Sumati gave me a correct answer. What do we do with null value here? P value. P value is this one. What do we do now? What is the next action? So yesterday we discussed several. I told you one thing very clear. Don't forget it, right? How about Mukilan? Mukilan is not there. Mukilan dropped off. And Mala, what is Mala or Parani? What does this p value says? Sumati gave only one person gave me the correct answer. How about others? So for all test, you take any test. In statistics, you will get p value, right? You can get the f statistic value in the case of ANOVA. Even the other two independent sample t-test, you will get the test statistic value also. But usually go by the p value because very simple. If the p value is less than which one? Less than which one we reject what? All of you please type it in the chat window. Reject null hypothesis, right? Reject null hypothesis, correct. P value is less than what? Here still I ask the question. Palani, are you there? Guys, don't get me wrong. During it is less than, yes, very good. Mala as mentioned very correctly. P is less than 0.0, right? So P is less than alpha value, which is nothing but P is less than alpha. Alpha is 0.05. Hence reject the null hypothesis. See, next week end we'll spend 1 hour time for you people to present it to us so that you will prepare well. And Palani, you are going to Palani and all the college, right, students, you present it together, okay? Reject null hypothesis so that you will improve your presentation skill also. I know very well, since you people joined in this call, it doesn't mean you're all sitting next to the laptop, okay? Still, right, p is less than alpha, reject the null hypothesis. In this case, p value is less than alpha. What is p? 0.00, right? So 0.000064 is less than alpha value 0.05, right? Hence we reject the null hypothesis, and we are going to conclude that there exists an association between the outcome and the hospital. Obviously, right? If you go and get a treatment in a government hospital, government hospital outcome, right? So the outcome depends on the hospital, type of the hospital. If the hospital is very premium, it is sophisticated with many. So if the hospital has many sophisticated equipments, other things, and and again top-notch colleges, those professors, those doctors studied, right? The success rate is very high, and many again experienced people. So what we conclude, we reject the null hypothesis. We are going to conclude the outcome is a categorical variable, right? So the outcome as an association with the hospital, okay? And Mayot hospital, the outcome, right? The outcome is depending on the hospital. So, and when we look at this one, we can find out easily, right? So Apollo hospital is far better compared to other hospitals, and this is how we can do it. So now we can. So this is the one, right? So you can use the chi-square test value also, the normal way of doing it. You need to do a lookup in the table. That's what the feedback which I got it from in this batch, not only in this batch, other batch also, right? when I start talk about the table, they are getting confused. Okay, and don't worry about that. Now we will go literally by the p-value. Okay, but that is the one is used widely by in you have seen in the Python also, right? Though it gives the statistic value for the ANOVA, and the again critical value and all, you need to use another function to find out, and difficult to remember all the things. Simply if you know the p-value, that is more. Even in this case, Tukey HSD test, we get the p-value. With that we can decide, right? So look here, even in this case, if you look at the p-value, that is more than sufficient. Statistic also it gives us, but you should be knowing the critical value for this one, right? So that is in that you need to go and do a lookup. Instead, literally go by the p-value. Since this p-value is less than alpha value, reject the null hypothesis. This is the same thing is applicable in Chisq Test. P is less than alpha, reject the null hypothesis. Jivan, are you able to remember it? Jivanandam. Okay, so don't forget this. P is less than alpha, reject the null hypothesis. Okay. Okay, next what we will do is we will jump into the introduction to